Here we are in section 4.4, which deals with the slope formula. So we have 6 warm-up problems, numbers 1 through 4. We're just adding or subtracting our integers. And 5 and 6, we are working on finding our x and y intercepts. All right, so let's check our answers here. I want to draw your attention to numbers 1 and 4. Remember, whenever we have 2 signs next to each other, we need to circle them and make them one sign. So if we have a plus and a minus, that comes together to make one minus. So we've got different signs, so we're going to actually subtract. We do 6 minus 4 gives us 2, but the sign of the larger number 6 is negative, so our answer is negative 2. In number 4, we had 2 minus negative 1. 2 negatives next to each other make a positive, so this was actually 2 plus 1, which is 3. And then 4, 5, and 6, we have our x and y intercepts. So I rewrote the equation for each of them so we could more definitively and visually see what exactly we're doing by plugging in 0 for y or just making those y terms go away in order to solve for the x-intercepts. So we're left with x equals 8. Therefore, it's the ordered pair 8, 0. For the y-intercept in number 5, when we make the x go away, we have 2y equals 8 is our equation that remains. We solve that by dividing by 2, so our y-intercept is 4, or the ordered pair 0, 4. Number 6, same idea. To find the x-intercept, make the y terms go away. We are left with 3x equals negative 15. Solve, and we get our x-intercept equals negative 5, or the ordered pair negative 5, 0. For the y-intercepts, we make the x terms go away. We have 5y equals negative 15. Solve for y. Y-intercept is negative 3, or the ordered pair 0, negative 3. So in our previous lesson, we did talk about slope, and slope was described as the constant rate of change of a line. And we found slope by doing rise over run, looking at graphs, and just kind of generally described the type of slope, positive, negative, undefined, 0, things like that. So we're going to get a little bit deeper into the literal finding of slope using a formula. And in order to use that formula, we're going to use this little piece right here, y2 minus y1 over x2 minus x1. So we need 2 ordered pairs. Okay, now slope is referred to as slope, but it's also the letter M. Okay, and from here on, anytime you see an M, it will represent slope of a line. Okay, and again, in order to find slope, we will need coordinates of 2 different points on our line. So here's a whole bunch of different ways that we can communicate that we're talking about slope, or our rate of change. So slope is equivalent to m, which is equivalent to rise over run, which refers to our change in y values over our change in x values, with delta y over delta x. Remember, those deltas refer to change in. And then here is our literal slope formula using those 2 ordered pairs. So all we're going to do, we're focusing on our y2 minus y1 over x2 minus x1. We're going to take 2 ordered pairs, and we are going to label them. Okay, so here's what's going to happen. The model is there, but I'm going to kind of just go straight to the first example to make sure that we are labeling things properly. And the labels, to me, are very important. So because we need to do y2 minus y1 over x2 minus x1, we're first going to write that formula over and over for every single problem. But what I need to do is I'm going to label my ordered pairs. So negative 2 is my first ordered pair. So this first negative 2 is the x-coordinate of my first ordered pair. So we're going to call that x sub 1. And the second negative 2 here is the y-coordinate of my first ordered pair. So that's going to be called y sub 1. Then my second ordered pair, the 7 is the x-coordinate of my second ordered pair, so y sub 2, and the negative 2 is the y-coordinate of my second ordered pair, so y sub 2. So now I have 4 numbers that are associated with each of these values, the x and y sub 1 and 2's. So we're going to take those values and we're going to plug them in. So the formula says y sub 2, so y2. Well, my second y is negative 2. So I've got a negative 2. Then the formula says minus, okay, so minus. Then it says y1. Well, my y sub 1 is negative 2 as well. Over x sub 2, so my second x value, which is 7. Formula then says minus x sub 1. Well, the first x is also negative 2. Okay, so it's important to note that these minus signs need to show up as a result of the formula, okay? And you're just inserting your different x's and y's in their relative positions, okay? So this is also why we did those integer rules and the addition and subtraction at the beginning, because we need to remember that, oh, we've got a double negative here. That turns into 1 positive. So this actually says then negative 2 plus 2 over another double negative, 7 plus 2, which gives us negative 2 plus 2 is 0 over 7 plus 2 is 9, which is 0. Okay, so our slope in our first problem is 0. I'm going to jump to number 3. Number 3, we have some fractions. It's not the end of the world. So let's write down our slope formula. And so I have more space. I'm going to write it up here. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to label each of my ordered pairs. Okay, so this is my first ordered pair. Therefore, 3/4 is x of my first. 7/5 is y of my first. 1/4 is x of my second. 2/5 is y of my second. So now I'm going to plug into the formula. So the formula says y2 is first, so I need 2/5. Then I need to subtract, put my minus sign. y1 is 7/5. Over x2 is 1/4. Minus, from our formula, x1 is 3/4. Now we're just going to clean up the numerator and denominator separately. So 2/5 minus 7/5, that technically gives me negative 5/5. Over 1/4 minus 3/4, that gives me negative 2/4. Going back into that numerator's fraction, negative 5/5 is equivalent to negative 1. And if you just typed your original subtraction from our numerator into your calculator, it probably just gave you negative 1 right away. And then our negative 2/4 is technically negative 1/2. And this is where calculators are very helpful. You can type into your calculator negative 1 divided by negative 1/2, and it'll give you the answer. But I'm going to walk you through the arithmetic here. First of all, a negative divided by a negative is going to give us a positive. And when I'm dealing with division and fractions, let's rewrite that as horizontal. And some people call it keep, change, flip. So it's 1 divided by 1/2 is what we actually have here. And with that keep, change, flip, we change it to multiplication and flip the second fraction. So we actually have 1 times 2 over 1, which is 2. So our slope in number 3, despite all of these ugly fractions, is 2. Okay, but you can use your calculator for help, but always make sure we follow PEMDAS. Clean up your numerator separately, clean up your denominator separately, and then you can do that division. Okay, so I would like you to do number 2 using this slope formula. I want you to rewrite the formula. I want you to label x1, y1, x2, y2 on these 2 ordered pairs and plug in. Make sure you're always duplicating the formula exactly as stated. All right, so hopefully you got a slope of 3. So y2 is -4 minus y1 is -7. So we have minus -7. So that -4 minus -7 will turn into -4 plus 7. Over x2 is 6 minus x1 is 5. So 6 minus 5. So -4 plus 7 is 3. Over 6 minus 5 is 1. 3 divided by 1 is 3. So we always want to make sure we fully simplify if possible. All right, so when finding slope, you're not always going to be given directly 2 ordered pairs. You may need to find 2 ordered pairs yourself using a graph or possibly pulling them out of a table. So number 4 and 5, we're going to find the slope in 2 ways. We're going to walk along our city blocks, finding our rise and our run, and we're also going to use the slope formula. So I have 2 ordered pairs in number 4 that I'm going to write out. So I'm going to put 4, 4 as my first ordered pair, and I'm going to label it x sub 1, y sub 1, so x of my first, y of my first. And then my other ordered pair is 8, 6. Okay, and these graphs are nice. They're spoiling you because they're giving you the clearly defined perfect points. Okay, but we do have other perfect points, okay, that occur on crosshairs right here, just in case you're ever given a graph that doesn't. So here's 8, 6. So that's my second ordered pair, so x sub 2, y sub 2. So now my slope formula is m equals y2 minus y1 over x2 minus x1. So using that formula, my m is equal to y2 is 6 minus y1 is 4 over x2 is 8 minus x1 is 4. So as long as we label, we have to think a lot less. We just look, okay? So now let's clean up. 6 minus 4 is 2. So we have 2 in the numerator. 8 minus 4 is 4 in the denominator. So 2/4 is simplified to 1/2. Now, if we do our rise over run, I start at my left point here. I'm going to travel to my right perfect point there by only going straight up and down and straight left and right. But I'm going to rise first because, again, it's rise over run. So my rise going straight up is 1, 2. Okay, so up 2. My run now, when I turn the corner, is 1, 2, 3, 4. And because I'm going to the right, that's a positive 4. So if I do rise over run, they were both positive, so my rise was positive 2. My run was positive 4. That also simplifies to 1/2 for my m, my slope. Okay, so an additional way to check our work. Let's take a look at number 5. We're going to pull out these 2 perfect points that are labeled for us. So I'm going to label them out here. My first ordered pair I see is negative 2, 4. So I'm going to label x sub 1, y sub 1. Then I'm going to label my second ordered pair down here, 0, negative 2. And that's x of my second and y of my second. And I'm going to rewrite again my slope formula. M equals y2 minus y1 over x2 minus x1. So I want you to go ahead and compute the slope of this line displayed in the graph using our slope formula and those 2 perfect points, and verify it with your rise and run. Okay, so for number 5, our slope is negative 3. Okay, and you should always do big idea checks, meaning in number 4, our graph from left to right is going up. Therefore, this slope will be positive, and we got a positive 1/2. So, seems reasonable. In number 5, going from left to right, this line is going down. Therefore, this slope needs to be negative. And when I do my y2 minus y1 over x2 minus x1 using my formula, I end up with a negative 6 in my numerator, divided by 0 plus 2 technically, because it's double negative. So 0 minus negative 2 gives us 0 plus 2, which is 2. And negative 6 divided by 2 is negative 3. If we count along our city blocks, okay, always go left to right and rise first, I had to go down 6 units until I got even with my next spot, my next point. So our rise was negative 6, and then we ran to the right, which would be positive 2 units. So the rise of negative 6 over the run of positive 2 simplified also to slope of negative 3. Okay, number 6 and 7, we're going to approach the same way. We've got some ordered pairs in a table, and we're just going to pull out 2 ordered pairs in order to incorporate our slope formula. Because as you can see here in number 6, we're missing a whole bunch of x's. We're not, here we're counting by 2, then we add 3, then we add 1. So we can't just look at the constant change in x versus constant change of y due to the fact that we don't have a constant change of x here just because there's some values that are eliminated. Okay, so let's take a look at number 6. I'm going to take 2 ordered pairs. Doesn't really matter which ones. I'll take the first 2. I like the first one especially because there's a 0 involved. And I don't hate any of them because they're all positive, and that's pretty easy to work with. So I'm going to label my 2 ordered pairs. I'm going to list them out. 0, 1 is my first ordered pair. So x of my first, y of my first. X sub 1, y sub 1. Then I've got 2, 5 is my second ordered pair. So x of my second, x of my second, y of my second. So here comes my slope formula. M equals y2 minus y1 over x2 minus x1. Yes, you need to know that slope formula. It is on the laminated reference sheet that I provided to you at the beginning of the school year. So you are free to use that reference sheet any time you want, including quizzes and tests. All right, so following our slope formula, y sub 2 is 5 minus y sub 1 is 1. So we've got 5 minus 1 in the numerator over x sub 2 is 2 minus x sub 1 is 0. So over 2 minus 0. That gives us 4 over 2, simplifies to 2. So my slope is 2. Let's do the same thing in number 7. I'm definitely going to pick the ordered pair 0, 0. It's easy to work with. And I'll go with the one right next door to it, 2, negative 3. So let's write out those two ordered pairs and label. So x of my first, y of my first is my 0, 0. For my second ordered pair, 2, negative 3. That's x of my second and y of my second. Again, I know it's annoying, but you need to know the slope formula. So anytime you have 2 points, the slope is found by y2 minus y1 over x2 minus x1. So you go ahead and find that slope. Okay, so our slope here is negative 3/2. We do like to see our slopes in fraction form. Unless it's a word problem, then we can possibly talk decimals. But any just normal math, algebra situation, use simplified fractions. Okay, so y2 minus y1 is negative 3 minus 0 over x2 minus x1 is 2 minus 0. So we have negative 3 over 2. You may have also noticed that in this particular situation, with my change in x's and change in y's, I do have a constant change in x's. From negative 2 to 0, I'm adding 2. 0 to 2, I'm adding 2. 2 to 4, I'm adding 2. So my change in x is plus 2. Okay, unlike number 6, I didn't have a constant change in x based on the data values that we had. Now if we look at our y's, 3 to 0 is a minus 3. 0 to 3 is minus 3. 0 to negative 3 is minus 3. Negative 3 to negative 6 is minus 3 again. So our delta y, change in y, is negative 3. And because slope is rise over run, which would be change in y over change in x, that means it's negative 3 over positive 2, which matches up. All right, let's take a look at number 8. Slope is technically rate of change, and in real world problems, finding the slope can give you information about how a quantity is changing. Slope is going to be really important in lots of real life situations. So number 8 says the graph shows the average electricity cost in dollars for operating a refrigerator for several months. Find the slope of the line, then tell what the slope represents. Okay, so we have a line, and it's super nice because 2 perfect points are already provided to us. So let's write those out. So my first ordered pair is 212. So that's x of my first, y of my first. My second ordered pair is 424. So that's 4, 24. So x of my second, y of my second. I'm going to write my slope formula for the millionth time. M equals y2 minus y1 over x2 minus x1. When I substitute my values in, my y2 is 24, minus y1 is 12. So 24 minus 12 over x2 is 4, minus x1 is 2. So over 4 minus 2. 24 minus 12 gives us 12. Over 4 minus 2 is 2. 12 divided by 2 is 6. So my slope is 6. Now remember what I said about it's nice when slopes are fractions. Because it fully simplified to a whole number, we're good leaving it like that. However, if I rewrite it as a fraction, meaning 6 over 1, we can throw some labels on here to help us with the interpretation, because remember, we don't want to recreate the wheel or have to think too hard. Now remember, this is rise over run or change in y over change in x. So here's what I'm going to do. Because the 6 is in the numerator, that's referring to change in y. So the y-axis labels refers to cost of electricity in dollars. So $6 over the change in x. The x refers to time in months. $6 over 1 month. So what does that mean? Well, the cost of running the refrigerator is $6 per month. Okay, it doesn't need to be hard. Okay, so the refrigerator costs $6 per month to run. Okay, so the electricity bill, $6 of it is a direct result of running the refrigerator. Okay, so throw those axes labels on and then interpret. Okay, so kind of reword it and write a sentence. Okay, I would like you to give number 9 a try, just like number 8. Okay, so I'll start with you, showing you, okay, we've got these 2 perfect points. My first perfect point is 30, 10. So x sub 1, y sub 1. My second perfect point is 50, 20. So x of the second, y of the second. Write that slope formula. M equals y2 minus y1 over x2 minus x1. Okay, find the slope. Tell me what it means. All right, so hopefully you found that our slope is 1/2 when we do 20 minus 10 over 50 minus 30. So now with the interpretation here, our change in y over change in x, the y refers to the height in centimeters, and the x refers to time in days. So it grows 1 centimeter every 2 days. And yes, we could say it grows 1 centimeter every 2 days, but we communicate things more in a unit rate, meaning, well, how much would it grow every 1 day? So if it's 1 centimeter every 2 days, if I literally think about that, okay, that's a half. Well, 1/2 is 0.5 per 1 day. Okay, so that's 1/2 centimeter every day is our plant's growth rate. Okay, so it's 1 centimeter every 2 days. It would mean 1/2 centimeter every 1 day. Now, just for the sake of time, I am going to skip the very last problem because we're going to have so many other ways of doing these problems. So we are going to call it quits here after number 9 and make sure that for our lesson quiz, we use the example problems as models. Okay, so number 1 refers to a couple problems that we did. Number 2 refers to a couple problems that we did. And number 3, we are going to skip for now. Okay, so only 2 lesson quiz problems.